This is CBSE NCERT Solutions, chapter number 5, Arithmetic Progressions, exercise 5.3. Question number 4. The problem is how many terms of the AP 9, 17, 25 and so on must be taken to give a sum of 636. Now basically they are asking us that how many terms of this AP we need to consider so that the sum of AP becomes equal to 636. Now let's suppose that n terms of AP must be taken to make sum equal to 636. Basically we have supposed that n terms of this AP make sum equal to 636 and we need to find the value of n here, which is the requirement of this problem. Now from this AP we can find the first term and common difference. First term is equal to 9 here, and first term is represented by small letter a, and common difference is equal to 17 minus 9, it's equal to a, and common difference is represented by letter d, and it is equal to the difference between any two consecutive terms. Now we also have a formula for sum of n terms of AP, which is equal to n divided by 2, 2a plus n minus 1 times d, where a is the first term of AP and d is the common difference, and as n is the sum of n terms of AP. Now we just need to fill the values in this formula. We already know sum of n terms of AP is equal to 636 because we have supposed it here. That sum of n terms of AP must be taken to make sum equal to 636. So we have here 636 equal to n divided by 2, 2 times a, the value of a is 9 and value of d is 8 here. So 636 times 2 is equal to n, 9 times 2 is 18 plus 8n minus 8 here. 632 times 2 is 1272, and I can multiply this n with 18, I get 18n plus 8n square, because 8n times n is 8n square minus 8n here. Now I get here 8n square, and 18n minus 8n is 10n, and I can bring this 1272 to the right hand side. I get 1272 here and I get equal to 0. Now this is a quadratic equation and we can further simplify it, because I can divide this equation by 2. If I divide both the sides by 2, I get 4n square plus 5n minus 636 equal to 0. Now I cannot further simplify this quadratic equation, and now we will solve this quadratic equation in order to get the value of n which we need to solve this problem. Now let's suppose that we want to solve this quadratic equation by using quadratic formula, and in order to solve quadratic equation by quadratic formula, we compare any given quadratic equation by general quadratic equation. Now general quadratic equation is an square plus a plus bn plus c is equal to 0. We have n here which is unknown, so that's why I have written quadratic equation in the form of n, so that I can get the values of a, b and c. Now value of a comes up equal to 4, b is 5 and c is minus 636, and the quadratic formula is n equal to minus b plus minus square root of b square minus 4ac divided by 2a. I just need to put the values of a, b and c. Minus b is minus 5 plus minus square root of b square, it's 5 square, minus 4 times a is 4, and c is minus 636 divided by 2a. 2 times a is 4. So I get here minus 5 plus minus square root of 25 minus 4 times 4 is 16. We get minus 16 here, and minus 16 times minus 636, we get here plus 10176 divided by 8. Now I get minus 5 plus minus square root of 25 plus 10176 is 10201 divided by 8. So I get here minus 5 plus minus square root of 10201 is equal to 101 divided by 8. So I need to consider both the signs here. For first case I'll consider this positive signs, and for the second case I'll consider this negative sign. So we get two values of n here. N is equal to minus 5 plus 101 divided by 8 and minus 5 minus 101 divided by 8. So I get here minus 1 plus 101 divided by 8, it's equal to 96 divided by 8, and here I get minus 106 divided by 8. I can ignore this value because number of terms cannot be in negative, or even if we get fractional value here, we will ignore this value because number of terms cannot be in negative or it cannot be in fraction. So I just need to consider this value 96 divided by 8, and 96 divided by 8 is equal to 12. So that's the solution, n is equal to 12. It means that we need to consider 12 terms of this AP, and sum of those 12 terms is equal to 636. So that's all about problem number 4, exercise 5.3, chapter 5, arithmetic progressions. In the next video I'll be covering question number 5, exercise 5.3, chapter 5, arithmetic progressions. See you guys.